Welcome to Python for Scientific Computing 1. In today's video, I'm going to give you a very short introduction to object-oriented programming paradigms. Object-oriented programming is a fairly advanced topic with a lot to cover. Nonetheless, having some understanding of object-oriented programming is important for you, especially to get comfortable with libraries in Python as well as some of the functionality of Python. So this video is largely guided by that motivation, which is to give you a familiarity with object-oriented programming, rather than teach you the details of this approach and how it can be implemented in Python. So without further ado, let's jump right in and get a quick overview of the OOP technology, or the object-oriented programming technology. Python has several programming paradigms built into it. We saw the procedural programming paradigm in this video series that largely comprises of conditional statements, for loops, if loops, and such. We also saw functional programming paradigms such as how to write functions, how to map a function onto a list of variables, how to use lambda functions or single line functions, and use them to drive programming logic. The object-oriented programming is the third biggest programming paradigm that is embedded within Python. Object-oriented programming builds on objects, attributes, and methods. OOP, or object-oriented programming, is a modern programming paradigm. It has become very popular in the last 2 decades or so. Objects are used as the basic building blocks, and you can think of all variables in Python as being objects. What objects do is objects are used to bundle properties and methods into a single variable. So the properties of an object are very similar to a noun. So they describe some characteristic of that object, such as the name, such as the color, things like that. Methods are functions that can be performed. So they're very similar to verbs in that you can use the method to do something on that object, or use that object to do something else. For example, you could have a matrix object and you could have a method that will help you get the inverse of that matrix. Object-oriented programming is built on what is known as the class, object, methods, attributes hierarchy. The class is your blueprint or the cookie cutter from which you can create objects. The idea of creating objects is called instantiation. So instantiation means you're essentially creating an object of a certain class. These objects inherit methods and attributes from that class. So objects have methods and attributes. Objects, the methods, as I said, describe the behavior of an object, whereas the attributes represent the state of an object or the characteristics of an object. As an example, let's think of a cat class. This is a class that defines domesticated cats. And this cat class has certain attributes that help define the cat, such as cats being fluffy, cats having 4 legs, cats having whiskers. An object that is a cat can also perform a few functions. The functions such as meowing or licking or jumping or purring, those are some of the functions that the cats can provide, or these are called cat methods. So a cat class has cat attributes as well as cat methods. For example, two of my cats, Suai and Dofi, are objects that have been instantiated from this master object called cat. In other words, I can define Suai and Dofi to be cats based on what I know about cats in general, right? So the cat class is what I know about cats in general, and Suai and Dofi are specific instantiations or objects that have been created from that cat. So when objects are instantiated from a class, they inherit properties and they inherit methods. Dofi and Suai both have 4 legs, they both have whiskers, and of course they can have different values for those different attributes. For example, you can see that Suai is lighter, it's got more white in it. Dofi, on the other hand, is a brown colored cat. So properties can take different states, and methods that can be performed can also vary slightly. For example, Dofi is a better jumper than Suai is. Dofi can fetch things, whereas Suai cannot. There are four major principles, all driven with one single goal. The single goal being you want to make this object uh, as easy and to reuse and as efficiently as possible. So object-oriented programming is built on code reuse and code efficiency. And the four main principles are: one is encapsulation. Encapsulation means you encapsulate both the methods and attributes or the data into a single unit called this object. You typically do abstraction. Abstraction means complex implementation details are hidden away, and you can simply reuse the object from a class via instantiation. Inheritance is the mechanism by which objects or classes inherit methods and attributes from another class or the master class or another object. Polymorphism means a method can have different results on different types of objects. For example, the plus operator, when applied to integers, leads to their addition, and when it is applied to different strings, leads to their concatenation. All of these are guided to make your code reuse easy and efficient as possible, which is why object-oriented programming is widely used in libraries, because the idea of libraries is to create functions, methods that are easy to reuse without having to go into technical details. This slide here shows how you can create classes in Python, how you can define attributes and methods. And once you create a class, you can use that to instantiate objects and then perform calculations using those. I'm not going to get into the details of this because this is just a slightly bit advanced topic to what we are trying to cover here. Nonetheless, it shows that you have the ability to develop object-oriented programming logic or implement object-oriented programming logic into your Python programming. What is, however, important when you work with objects is this concept of dot notation. Dot notation makes it extremely easy to acquire or access those methods and attributes associated with an object. So this is what makes object-oriented programming very appealing, particularly for development of libraries. Here I'll show you an example. I'm going to import NumPy as an NP. NumPy stands for Numerical Python, and it is a library that I'm going to import with an alias of NP. Okay. Then what I'm doing here is I'm defining X, which is a list of lists. You can see that the master list contains 4 sublists, and each of that sublist contains 3 elements. So what I want to do here is I want to call a function from NP called np.matrix, and then I'm going to pass this X as an argument to that function, and I'm going to create a new NumPy object called xmat. Now xmat has an attribute called shape, and if I say xmat.shape, I can access that attribute, and it prints out to me a tuple 4 comma 3. 4 comma 3 means it's got 4 rows and 3 columns. The 3 columns correspond to the 3 sub-elements of that list, each sublist, and then the four rows correspond to each of the sublists that's in that master list. Xmat, or this matrix object xmat, also has a method called transpose, and I call that transpose with parentheses to indicate that this is a method that I'm calling. And as you know, a transpose essentially transposes the rows and columns. So if I do xmat.transpose, I have created an object that has essentially got 3 rows and 4 columns instead of 4 rows and 3 columns, which my original object xmat has. So again, dot notation is used to access the attributes and the methods of an object. And then if you have an attribute, you don't put parentheses. If you have a method, you put parentheses. Sometimes you have to give arguments to that method as well. So methods are functions that are embedded within the object, and then and then attributes are features that describe the object and are embedded in that object as well. So this idea of embedding both the attributes and the methods is called encapsulation. Functions are written with the dot following the module. So for example, I have np dot matrix. So basically matrix is a method that is in this object called np that I'm instantiating from my NumPy library or the class NumPy. So you can think of object-oriented programming language being hierarchical and working at multiple levels. A few more examples of dot notation. So you can see here, I have native Python list X. I can do X dot sort. And if I do X dot sort without anything, it will sort ascending order. And similarly, I can take a string and convert the whole string to an uppercase, which is what the string.upper method does. So you can see that native Python by itself allows for some object-oriented programming concepts or objects. And similarly, if I have libraries, the libraries make use of this concept as well, as we saw with NumPy. So in summary, Python, in addition to procedural programming language and functional programming paradigm, also supports the object-oriented programming paradigm, which is very useful for the development of new data structures, and hence they are widely used in libraries, which provide us with additional functionality and new data structures. OOP is based on the class object attribute value hierarchy. Essentially, the object is instantiated from a class, and when it does, it inherits certain properties. These properties are either attributes or methods, and then those attributes can have different values if to differentiate one object from another. The dot notation, extremely useful to access the attributes and methods of an object. When you access attributes, you don't put parentheses, but when you access a method, you have to have parentheses and sometimes pass additional arguments in as well. Dart notation is also useful with some native Python objects such as lists and strings, but their utility comes into prominence when we are working with libraries, which we are going to do in the remainder of this class. So I hope you found this quick introduction to object-oriented programming useful. Again, I will point out some of these as we work with dot notation in subsequent videos, but having an idea of what this dot notation, where it comes from, how it relates to object-oriented programming, is useful for you to better understand Python codes and use these objects more effectively in your scientific computing endeavors. I hope to see you in the next video. Till then, take care and goodbye.